In this video, we will be transforming cubic and quartic parent functions. So this is our transformed cubic parent function. So y equals x cubed is transformed to this. And this is our transformed quartic function, y equals x to the power of 4, gets transformed in this way. So we can use our ordered pair notation. So a point xy will be transformed to x plus d ay plus c. Note there is no k value. I'll tell you later about why that is. Or what you can also just do is transform your vertex. So 0, 0 gets transformed to dc. And then your step pattern is multiplied by a. I'll give you an example of how I would use each. This I find easier. First of all, to be able to transform, we need our key points. So the key points of a cubic, let's start -2, -1, 0, 1, and 2 for our x values. And to get our y value, we cube that number. So -2 to the power of 3 is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. We'll use the same x values for the quartic. But to get the y value, you raise that x value to the power of 4. -2 to the power of 4 is 16. 1 to the power of 4 is 1. 0 to the power of 4 is 0. 1 to the power of 4 is 1. And 2 to the power of 4 is 16. So as a reminder, this is your x cubed. And this is your x to the power of 4. So to graph this function, let's do it using the transformations. So xy would move to, okay, so what's happening? We are shifting it to the right by 2, so x plus 2. And our y values are being multiplied by half and then added, and then 5 is being added. Okay, so taking our points, -2, -8, just copying them down from up above. Okay, and then usually I go through and I do all my x's at once. So -2 plus 2 is 0, -1 plus 2 is 1, 0 plus 2, 1 plus 2, and 2 plus 2. I always like the pattern that will form. Then I'm going to multiply my y's by a half and add 5. So -8 times a half is -4, plus 5 is 1. A half times -1 is -1/2, plus 5 is 4.5. A half of 0 plus 5 is 5. A half of 1 plus 5 is 5.5. And half of 8 is 4 plus 5, which is 9. Now, plotting my points, I have 0, 1, 1 and 4.5, 2 and 5, 3 and 5.5, 4 and 9. And I'm going to join them into a smooth curve that flattens out in the middle before increasing. Okay, that's not the smoothest, but I think you will do better with pencil on paper. So this method is okay. It can take a little bit of time, so I'm going to show you how to do it just by using the transformations. So normally there's a key point at 0, 0, and it is shifted over to dc. So 0, 0 will be shifted over to -1, 0. And then I will put that point there. And now normally the pattern is like over 1, up 1, over 1, up 1, and over 2, up 16. and those points are going to get doubled and reflected. So I'm going to go over 1, and instead of up 1, I'm going to go down 2. And because this is symmetrical, over 1, down 2. And then my next point would be over 2, down 16. So, my normal point would be over 2, up 16, but multiplying by -2, that means over 2, down 32. So that's not going to fit, meaning I will just join this. Okay, it's actually really flat up top. It's not as pointy as you might think it is, or even how that looks right now. Okay, so just to show you, this is what it looks like on Desmos. That is a nicer graph than what I was able to draw. So nice and flat around this turning point. So your other skill will be to look at a graph and determine the equation. So this is a cubic function, and our cubic is of the form y equals a x minus d cubed plus c. So we know normally a cubic passes through 0, 0. The center point of this cubic is actually at -4, 2. Meaning our cubic has been shifted to the left 4 and up 2. Meaning in here we will have x plus 4 and then a plus 2, right? Because this is our shift left of 4 and up of 2. To find the stretch value, we need to sub in another point on this and use a nicely labeled point, because here we can't tell what sort of decimals are involved in the point. So I'm going to give you a labeled point. We're going to sub in -2, 2 to find our a value. Remember that our x and y are represented in this order. So I'm going to sub in -2 for y and -2 for x. I can move that 2 over. This is going to be 2 cubed, which is 8. And a will be -4 over 8. Always simplify your fraction, so this is -1/2. So our equation is -1/2 x plus 4 cubed plus 2. So those are the two main skills: how to graph given an equation and how to write the equation given the graph. So another skill is to be able to determine the zeros. So remember, to find a zero, we let y equal 0 and we solve for x. So if y is 0, what can we do to isolate our x value? We will start by moving the 5 over and making it negative. And then our right side's being multiplied by 1/2 or divided by 2. So we can multiply the right side by 2, so we get -10 is x minus 2 all cubed. So to further isolate for this x, we need to take the cube root of -10. And then to get our x is the cube root of -10 plus 2. Using a calculator, the cube root of -10 plus 2 is about -0.15. To solve this, we will let 0 equal our equation. I will move the 48 over. I will divide both sides by 3. And when our power is even, there are going to be positive and negative roots. When it's odd, there is only one cube root of a negative number to give you, well, the answer. But there are always 2 roots when the exponent is positive. So either x plus 6 is positive 2 or x plus 6 will be negative 2. So x will be negative 4 or x will be negative 8. Okay, and that makes sense. Thinking about this shape, we've got something that's moved over 2, up 5, and it has, this type of order, this type of end behavior, sorry. So we can see there is one x-intercept. And over here, we've moved left 6, up 48, and we're opening down. So definitely my scale is not correct, but we can see that there will be 2 zeros, which are the 2 answers we got. So finally, why don't we need to consider the horizontal stretch and reflection in the y-axis? Well, this has to do with our properties of exponents. Say if we have a product raised to a power, we can actually put that power on each factor of the product. So here I've got a value of 2, a k value of minus a fifth, and then our horizontal shift of 7 to the left, and minus 4 is our vertical shift down. But what I can do is I can put this 3 on that bracket and on this number, on our k value. And then negative 1/5 cubed is just negative 1 over 125. And then I can just combine these two, so it's negative 2 over 125, x plus 7 cubed minus 4. So because of the rules of exponents, the k value can be combined with the a value. Okay, and then if we can combine it, then there is no need to consider it separately. We will just see it as a combined vertical stretch. So that's how we work with transformations of parent functions, graphing them, writing their equations, solving exactly for their intercept, and a little note on why, after reviewing the k value, we never use the k value.